Okay, so here's your h. Here's your t squared plus 6t. We're going to call these little green ones t. And plus 13. Okay, so what we want to do is we want to make it look like the form h minus something. Let's just call that an unknown for now. Got my eraser, that's not looking very neat. We're going to put it in the form, it looks like h minus some number equals x plus or minus some number squared, which is what completing the square is all about. So I'm just going to erase that for now, but keep in mind that's what we're looking for. So we're going to use these algebra tiles. I'm just going to take my blue away, and we're going to the first step usually I try to do is, because I want it to be a square on this side, this is balanced, it's an equation. I want to be a square on this side. So what I'm going to do is I'm going to get rid of these red ones by adding a negative and making it 0. So we can take some whites and add them there. So I'm going to add 13 negatives here. Let me just get rid of this blue again. Oops. I'm going to take and add 13 negatives to cancel out the 13 positives on this side. So if you take a plus 13 plus a minus 13, that'll give you 0. And we like 0 because it makes stuff go away. And just going to keep going here. Oops. Okay. But what happens when you add negative 13 on this side is all of a sudden now your balance is all out of whack. Oops, too heavy on this side. So we have to do the same thing to the other side. So we're going to add 13 negatives over here. Whoops, didn't mean to add a red. Let's make sure that's a white. I'm going to just cheat and clone these. Oops. Okay, so now there's 10. And we'll just add 3 more. Make sure we have the right amount. Okay, so what we now have on this side is h. Oops. Let's grab the pen again. On this side is h minus 13. And what we have on the other side, this goes to 0. So it's gone. And on the other side we have t squared minus 6t, or sorry, plus 6t. It's positive. All positive. Okay. So these two things are equal. And that's the first step. So now we're going to think about this t squared plus 6t. So I'm just going to drag these down here for the time being. Oh, let's get rid of that. So here's my t squared. And in order to fit 6t to make a square, if you think about 6, we could put 3 and 3 on either side. And let's grab these ones. These ones we're just going to rotate. Oops. I'm going to rotate them and put them down here. Okay, so now we have what would be called almost a square. It's x plus 3 by x plus 3. And those are the dimensions of our square, or sorry, t plus 3. I'm using the wrong variable, but it doesn't really matter what variable you use. T plus 3, t plus 3. But what happens is our square is incomplete. There's something missing here. In fact, what would go in here is something that's 3 by 3. So what would fit in here is 9 of these little red ones. And it takes 9 of these squares to complete the square. And that's where the term completing the square comes from. You're actually completing a square. So if we fill those 9 in, this is our complete square on this side. Oh, come on. That's so difficult. There we go. One more. No, not that. Of course, I could have used that junk to find a red. Just get that out of the way. There's our little red. Okay. So, now, what we've done is we've made a complete square on this side that has dimensions t plus 3 by t plus 3. However, again, we have unbalanced our equation. And so since we added 9 little reds on this side, we need to also add them on the other side. And so I'm just going to take 9 and put them over here. So 9 of these positives on this side is going to cancel out 9 of those negatives. So what we're getting then is h minus 13 plus 9, which, again, 9 of those red cancel out 9 of those white, which is going to leave me with h minus 4 on this side. And on this side, we end up with kind of a total area of t squared plus 6t plus 9, which now is a perfect square, and we can factor that because each side is t plus 3 long. So it becomes t plus 3 times t plus 3, or t plus 3 squared. And now this is our formula in a completing the square. The square is complete. Okay, so we have h minus 4 equals t plus 3 squared. And the first thing we want to do is look at the graph of this. So my x-axis, or my vertex along the x-axis, is at -3. So that's where we are along the t-axis, actually, in this case, and +4. So if we look at a graph of this, we actually have a graph that opens up, and it's situated back 3 and up 4. 1, 2, 3, 4. And what we see is that this will be a parabola that opens up. So it is never going to touch the h-axis, or never going to touch the t-axis. So this is your t-axis. This is your h-axis. So it's never, h is never going to be equal to 0 because of the kind of graph that this is. So for this one, there are no real roots. Now, you could find imaginary roots depending on what grade you're in. So if you're doing complex numbers, how I would solve this is 0 minus 4 equals t plus 3 squared. So imagine if the height could be 0, which from the graph it can't be. But if the height could be 0, we would have then -4 equals t plus 3 squared. And then we'd want to take the square root of both sides. And you can always take a positive and a negative square root. So the positive and negative square root of -4 is equal to t plus 3. So then I would subtract the 3 or add a negative 3 might be a better way to describe that, and add a negative 3 to this side. So this would give me negative 3 plus or minus the square root of negative 4. Oops. There we go. Of negative 4 is equal to t. And when we learn complex numbers, you can see that negative 4, you can't really take the square root of that, but you can take the square root of positive 4, which is 2 times the square root of negative 1 equals t. But we develop a constant for the square root of negative 1, and we, for some reason, call that I, an imaginary number. So it would be negative 3 plus or minus 2i is equal to t.